Okay, so under the today's lesson, like we need to discuss about the chemical reactions. Chemical reactions. We last day we just identified the difference between the basically difference between these physical reactions and chemical reactions, right? So we just identify what are the differences. So the physical changes and the chemical changes. Physical changes basically will not do anything to the composition or the resultant like in the physical changes, like tearing a paper. Just think about that. So we just discussed this last day. If you tear this paper, you will get the papers, same material. There will be no material change, right? But it is a physical change, but it is not a change of composition. So same material and the same behavior is there in that material, but there will be a composition change. Actually, some new substances will form in the chemical changes. That is the difference. We just identified that last. And now actually we need to look at some examples. We are here. We need to look at some examples and do the practical and discuss the practical things related to these chemical changes. Okay, so here we are given few changes. Few reactions actually, and then they have asked me to fill a table. So I'll give this table, but before that, let me discuss some examples for the chemical reactions. So how this composition change can happen, how the composition change means like the new substances will form, new solutions will be there, and so then the composition, right? Composition will be different composition will be there after the result. So let's see how these changes are happening. Let's go to the presentation quickly. So this is actually, so one practical is the thermal decomposition of lead nitrate. So lead nitrate is basically, you can take lead nitrate, lead nitrate is in lab, it is a solid, right? You can see the S state refer to the solid. So lead nitrate is a solid. So the color of lead nitrate, basically it's in white color. So if you go to your school lab, you can see this is lead nitrate. And so it is like white color dust. This is it, right? So white color dust, and this is lead nitrate. So the I hope that so this part is anyway. So this the symbolical notation is not there for your grade. So let's refer to the book. Is it there? Lead nitrate? No. So you just in there you can just see the name lead nitrate, right? Lead nitrate, then the boiling tape and the Bunsen burner is needed for this practical, and you can only see the name. But it is okay, like if you can remember this chemical formula, that is also a benefit, because like in next grades, in future grades, we are going to learn about this chemical formula. Pb is basically lead. So Pb is lead. I hope that I have introduced you this P table this one. So please go through this and try to remember these components, right? And the symbolical name as well as the symbolical name and the real symbolical name and the English name. So try to remember both, like at least. So no need to remember for all the materials, but just go through this. So I'll send this to you. Just go through this and so try to remember these things, like the names. H is symbolical. H is for hydrogen. You can see H and hydrogen. The name is there. Then Li is capital L, simple I. That is lithium. No need to remember. No need to remember this atomic mass and the weight. No need to remember these things, atomic number, weight, and all. But just the symbolical letter, as well as the name. H for hydrogen, Li for lithium, Be for beryllium, right? He for helium. Actually, you can see the status also, right? Status also, there is a place that you can see the status. Where is it? Here. So if so helium. So what is the status of helium? H is helium. What is the status of helium? Just refer to the font color. According to font color, what should be the status? Yes.
Liquid.
Solid, liquid, or gas?
Liquid.
You have to remember by this letter format, right? This H. Can you see? When you go there, it will be highlighted. So these red color things are gases, right? These red color things are gases. Actually, it is basically shown using the red color font. It is displayed to you using red color font. So hydrogen is a gas. H. Hydrogen is a gas. Helium is a gas. Nitrogen is a gas. Oxygen is a gas. Fluorine is a gas. Neon is a gas. Chlorine is a gas. Argon, krypton, xenon, then radon. So these are gases, right? So then the liquid state, basically think about the temperature also, right? This is the temperature. This is 0 Celsius. But in the room, what is the room temperature? Normally, what is considered as the room temperature? Room temperature is considered as 25 degrees of Celsius, right? 25 degrees of Celsius is considered as the room temperature. Okay, let's increase that to 25 degrees of Celsius. That is 77 Fahrenheit and 298 Kelvin, closer to 300 Kelvin. So that is considered as basically the room temperature. And in the room temperature, you can see, again, if I refer to this, all are gases. So the liquids. So you can see these are liquids. So what are the liquids in the room temperature? Yes.
Francium.
Francium, yeah. Then
Mercury.
Mercury, Hg for mercury, and bromine, right? Br, bromine, mercury, and francium is basically in liquid states. So do we have gallium somewhere? Can you see gallium? Should be there. G. Here, gallium. So gallium, can you see gallium normally when, let me increase the temperature a little, right? I'm going to increase it. So please see this gallium. I'm going to increase the temperature. Okay, you can see now temperature is 31 Celsius. So what will happen to gallium?
Liquid.
Gallium is a metal, but it will become liquid. I'll show you because I have some sample. I'll share some videos from Steam. So please look at my channel. So actually I brought some gallium. And so that is basically, so I cannot keep that as a solid state because when like normally in our environment, normally this closer to 31 degrees now. So gallium is in the liquid state. When I put on top of my hand, when I keep that in my palm, so it will become liquid. So gallium is a metal, therefore I can create different materials. That is, there are interesting videos related to gallium. You can also see this gallium, right? This is actually a metal, but when you keep this in your hand, it starts melting. It's like this. It's not poison. It's not poisoning now. It's not damaging your skin. Don't worry. But so when you keep it in your hand, palm, actually it will become liquid. There is emission metal, right? So basically, this can be used as a metal to create different objects like coins, different shapes, maybe different objects. So these are gallium. You can create different metals using gallium. But the thing is, it melts, right? In the room temperature, not in the room temperature, but so basically when it is closer to 30 degrees, it melts, right? But so I think you know about mercury, right? Mercury.
Yes, sir.
Mercury is used where? Mercury is used. Mercury is used in. There's a place.
Thermometer, sir.
Sorry.
In thermometer.
Thermometer. So mercury is used in. Why it is used? Because it is a metal again. Mercury is a metal, but it is basically in the room temperature, you can see it's a liquid. So in the room temperature, like basically 24, 25 degrees, in the room temperature, mercury is there as a liquid. Right? It's a metal. It's there as a liquid. So it is sensitive to the temperature. when the temperature increases, what will happen? The temperature increase. When temperature increases, yes, mercury will expand. So that is used for that is used in this thermometer to measure the like temperature. Okay. So therefore, that's why I asked you, please go through this. H for hydrogen, He for helium, neon, oxygen, for fluorine, neon, then chlorine, argon. So please be familiar with these symbolic names. Then these are the liquid and the solid. Lot of things are in solid status. You can say lithium, beryllium, boron, carbon, magnesium, sodium, aluminium, silicon, phosphorus, sulfur, potassium. So please remember the symbol. Symbol is different. K is for potassium, Na for sodium. Right? Na for sodium, K for potassium. So no need to divide this to groups, but just remember at least the symbol and the name. That is enough. Okay, then let's move to the thermal decomposition. So here Pb, what is Pb? Pb is for
Lead.
lead. N for?
Nitrate.
No, N for nitrogen. O for?
Oxygen.
Oxygen, correct. Right. Pb for lead, N for nitrogen, O for oxygen. Actually, this shows, like this reaction shows PbNO3. PbNO3 is basically PbNO3 twice, this 2, NO3 2. So this is basically, we call lead nitrate. In lead nitrate, how many lead elements? Lead components? Right, one lead component. How many nitrate components?
3.
No, 2 nitrate components. Right? Nitrate means NO3 is nitrate. So there's no need to remember this, but just understand, try to understand. So this is like, when let me write like this. So lead nitrate, you can write this as lead is Pb. Pb is lead. Pb is lead. Okay, Pb is lead. The nitrate means NO3 is nitrate, right? NO3 is nitrate. Pb is lead, NO3 is nitrate. But when you combine Pb and NO3, you cannot call that lead nitrate, because you need 2 nitrate components. You need 2 nitrate components to form the lead nitrate. Understood? 1 lead and 2 nitrate components. Inside the nitrate, you have nitrogen and oxygen. How many nitrogen components in nitrate?
1.
1. How many oxygen components in nitrate?
3.
3. Okay, that is what. Okay, now I think you can understand the symbolic notation. Okay, let me show that in a picture. Lead nitrate. Okay, here, this is what the lead nitrate is. Okay, here. 1 lead, right? So this is nitrate component. 1 lead component, and this is, let me show. This is a nitrate component, and this is another nitrate component. How it is bound to this, how it is connected to lead using the oxygen molecule. The bond is between the lead and oxygen, right? Here, this lead and oxygen component has a bond. This has a bond, lead and oxygen, and this lead and oxygen has a bond. But this oxygen is connected to this nitrate component. This oxygen is also connected to this nitrate. This is what NO3. This is what NO3. Okay, NO3 means nitrogen and 3 oxygen together. Nitrogen and 3 oxygen together. When you combine it to lead, it is lead nitrate. Understood?
Yes, sir.
Okay. You don't have this molecular views and bonds. Still, you don't have that, right? So, but in future, we will just try to understand how this is connected and all. Okay, anyway, lead nitrate. So it is white color compound. So what will happen when you put it to a burn tube and burn it, it will form brown color gas. That brown color gas is nitrogen dioxide. So you can see in this test tube, there is a brown color gas. That is nitrogen dioxide, right? The brown color gas is nitrogen dioxide, and it will also emit oxygen. Not only nitrogen dioxide, it will also emit oxygen. So how can we identify oxygen? Is there a way of identifying oxygen? Yes. Is there a way of identifying oxygen? Oxygen අඳුරගන්න පුළුවන් විදිහක් තියෙනවද? Yes.
Sir, ඒ ගෑස් තියෙන තැනට හඳුන් කුරක් වගේ දැම්මහම පත්තු වෙනවනම්
කොහොමද එහෙම ඔක්සිජන් කියන්නේ? වයි ඇයි එහෙම පත්තු වෙන්නේ හඳුන් කුරක් වගේ දැම්මම?
දහනයට ඔක්සිජන්
සර් මේ කියන්නේ දෙයක් පත්තු වෙන්න ඔක්සිජන් ඕන නිසා
ඔයාට මතකද, can you remember that we have done small practical, right? We have done small practical using the candle, right? If you can remember that, I have explained this. When a candle is lightened up and when you close it using a glass, right? Here, experiment, I need the experiment, right? Okay, this part. You can do this at home, it's very easy, practical. You can lighten up a candle and then close using a glass. What will happen? What will happen after some time? Will
The
candle like burn forever, or will it be stopped? So what do you think?
sir.
It will be stopped like this, right? Yeah, after few seconds, the candle will not burn, like candle will stop burning. So after few seconds, this will happen. So why? What's the reason? Because there is amount of oxygen inside this glass. This is a complete system. It is completely closed, so no way to pump oxygen here. So what will happen? So after some time, right, after maybe few seconds, this will not take that much of time, only few seconds. Within few seconds, oxygen will be over. When oxygen is over, this will be like, this will look like, so the candle will simply go. The reason is you don't have enough oxygen. If you try to lighten up this immediately, so try to do this like at home, try to do this, try to light up this immediately. Then what will happen? If you try to light up this immediately, again, it will not start firing. The reason, you cannot see, it will not be burning. The reason is, so still there is not enough oxygen inside this glass. But you have to take the glass out, expose this to the normal environment, right? Expose this to the normal environment, and after that, if you put this again, then again you can keep this for some time. So this proves for fire or for burning, oxygen is required. Without oxygen, it is not possible to burn. Another thing, so have you heard that in the mining industry, they are basically using candle to test the oxygen level. Right? ඔය පතල් එහෙම හාරගෙන යද්දි ඉස්සරහින්ම යන කට්ටිය සාමාන්‍යයෙන් candles අරන් යනවා. ඒ කළුවර හින්දාත් අරන් යනවා. එහෙම එක උත්තියනවා. හැබැයි candle එක නිවෙන්න යනවා නම් ඒ කියන්නේ oxygen මදි. So it is risky to go inside. So they are testing that using candles. Normally අර ගැඹුරු තැන් වලට යද්දි candle එකක් අරන් යනවා. මොකද oxygen මදි වෙනවා නම් ඒක නිවෙනවා. දෙක පත්තු කරන්න බෑ. පත්තු කරන්නත් බෑ, නිවෙනවා. ඒක නිවෙනවා කියන්නේ පොඩ්ඩක් dangerous. You need to quickly move away because the oxygen level is dropping. So that is another usage or another place that we are identifying. It is necessary to have oxygen for burning or fire. Without oxygen, that will not happen. And that can be used to test the oxygen. Basically, you can put a joystick, or you can just put some, maybe even you can put a something like burn match, and you can see the brightness will increase. Why the brightness will increase? The reason is the oxygen is emitted. Since oxygen is emitted, that will increase the brightness of this joystick. Okay, so this will form basically red color dust like thing inside the test tube. There will be, so that is lead oxide, right? So if you haven't seen lead oxide, this is it, lead oxide. Okay, it is basically this red color dust. So, but not it will not be like close. It will not get this color, but closer to this color. You will get closer to this color. This is actually, I think, color enhanced or something, because of the picture. You can see some enhancement. But anyway, so do the experiment, then we can see this with the real color. In this my slide, it is not. Yeah, you can see here slightly. You can see it, but it's not properly visible. Okay, this is called thermal decomposition. Thermal decomposition means you can see still there are original elements. Originally there was lead, and lead is here. Originally nitrate was there, and you can see nitrogen inside nitrogen, NO2 to NO2, 2 oxygens and 1 nitrogen is here. Another 1 oxygen is here. Another like 2 oxygens, 2 oxygen molecules are here forming oxygen gas. And nitrogen dioxide is also a gas. Lead oxide is a solid. S means solid. Okay, this is called thermal decomposition. The reason is basically it will break down into the normal element. Here you have taken 2 lead elements, so you can see 2 lead oxide. Let's count the elements. Let's count the Let's take the count of this. How many lead molecules are there? There are 2 lead molecules. 2 lead molecules, and since there are nitrate, 2 nitrate molecules, and 2 times of that will be then here 2 nitrogen, 2, there will be 4 nitrogen molecules. And how many oxygen molecules? How many oxygen molecules?
6.
Here 3, then 3 into 2 is 6, but that you have to multiply by 2 again, right? Why? 2. This reaction need 2 lead nitrate. Therefore, there will be 2 into 3 is here 3. 3 into 2 is 6, and 6 into 2 is 12. 12 oxygen. Okay, check that it is there in the output, right? How many lead here? You have 2 lead elements, right? How many oxygen elements? Can you count? Here you have 2. Here 2 into 4 is 8. 10 plus 2 is 12, right? Understood how I counted?
Yes, sir.
Okay, so here 2, here 2 into 4, 2 into 4 is 8. Here 2, altogether 2 plus 8 is 12 oxygen. And how many nitrogen? Here you have 4. So can you see, is there anything new, or all the things that were there is presented as the output? Only the composition is different, but the thing is, you can see similar. So nothing added, right? Nothing added or nothing removed. Everything is here. So therefore it is called decomposition. Decomposition means breaking down into small elements. So please write down the term decomposition. Within bracket you can write down breaking down into same set of elements, molecules, but it is actually molecules breaking down into same set of elements or the molecules. But you cannot say molecules since there are bonds. So these are composition, compounds. So you cannot just say it is molecules, but because it is not divided into original molecules, what it shows is basically some other compounds using those molecules it forms. That is called decomposition. Okay, just write thermal decomposition of lead nitrate. What will happen? So no need to know about this formula and the symbols. That is just some guidance, but no need to know about that. But what you need to know, that there will be a gas, there will be two gases. So one gas is nitrogen dioxide, that is in the brown color. Another gas is oxygen, that is what motivate in this fire, or that is what like increase in the fire. So nitrogen dioxide is gas, oxygen is gas, and you will get lead oxide, which is a red color dust. That is the output of burning lead nitrate in this tube. Okay, so that you need to fill in that table, right? The particular part you need to fill that in the given table. Okay, next. Shall we go to the next? Or do you need more time? Okay, take your time and tell me once you're done.
Finish, sir.
Okay. Next. So this is called single displacement reaction. Actually, you don't need to remember this as well, but displacement is, so can you see the colors? So then identify what will happen here. You can see this orange color one or the brown color one is actually reacted with this blue color and green color one. As a result, a green color one is formed, and then this the single orange color, the brown color one is combined with the blue color one. What has happened? Okay, let's see. There is this element is X, and this element is A, B. Give me a few seconds. I need to reconnect to my Wi-Fi. Just give me a few seconds. Okay, single displacement is something like this. In single displacement, so let's see. Let's give some letters to identify this. Let's say A is one compound or one element, and there are two other elements called B and C. So when A is reacted or A is mixed with B and C, so it forms, right? It forms one element is basically removed here. You can see one element is displaced. Now you have only B. The other element is displaced, and now it is mixed with A. So you can say this is AC, right? ABC reaction will form BAC. Still, nothing came new. Nothing new, has no new components, no new elements are there. No, nothing new, but existing elements. So it will displace only one. It will displace only one component. Then we call single displacement. For example, copper sulfate and iron nail reaction. So when you put a nail into copper sulfate, what will happen? Actually, in nail you have what Fe is. Fe is for. Fe is for. Let's refer to the table. P table. So what is Fe? Can you see Fe, C? Check where's Fe. Hello? What is Fe?
Iron.
So where's it? In which? What is the number?
Iron.
Yeah, what is the number? It is iron, correct. What is the number in this table? Iron කොහෙද තියෙන්නේ මේ table එකේ? පාගල දෙන්න. බලන්න. එකෙන් බලාගෙන යන hydrogen, helium, lithium, beryllium, this fluorine, neon, zinc, gallium, germanium, likewise තියෙනවා. ඒතර iron කොහෙද තියෙන්නේ? ලේසි. පළවෙනි 30 ඇතුලේ තියෙනවා. It's within first 30. Cannot find? My God. Here, Fe is iron. It's here. 26.
26.
It's 26, right? Fe is iron. It's in the 26. So Fe is what? Is it a solid, liquid, or gas? It's a solid, right? It's a solid and it is a metal. Iron can a solid එකක්, metal එකක් ඒ වගේම. ලෝහයක්. හරිද? එතකොට ඇන හදන්න ගන්න ඔය ferrous කියලා අපි කියනවා. ferrous ferric oxide කියලා කියන oxygen එක react කරාම ඒ වගේ ඒක iron, right? එතකොට Fe කියන එකෙන් තමයි අපි පාවිච්චි කරන්නේ. So let's go to that presentation again. You can see Fe, iron nail, is reacted with copper sulfate. What is the color of copper sulfate? Copper sulfate? Blue color. Yeah. Blue color copper sulfate. Once iron nail is put into that, you can see in the nail, so inside this solution, the solution will turn into light green color. Solution will turn into light green color, forming ferric sulfate. Right? Then you can say iron sulfate. Okay, iron sulfate, ferric sulfate, anyway. So then the copper nail, so will turn into some like a brown color. It's not brown actually, but it will turn into copper color. තඹ පාට වෙනවා. මේ ඇනේ මේ කෑල්ල දැන් මුල කෑල්ල නිකන් තඹ ආලේපිත ඇණයක් වෙනවා. උඩ ටික යකඩ පාටයි. යට ටික දැන් මේ වතුරට නේ copper sulfate වලට දාපු ටික තඹ පාට. The reason in this reaction, so the iron nail is put into the copper sulfate solution that will form iron sulfate. Iron sulfate and copper metal will be there covering the iron nail. But this will not become a copper. This will entire nail will not become copper, right? එහෙම වෙන්නේ නැහැ මුළු මේ දැන් ඒතකොට හරි ෂෝක්නේ නේද? යකඩ හැන ටික ඔක්කොම තඹ වෙනවා. එහෙම වෙන්නේ නැහැ. මේක අර වටේ තියෙන ටික විතරක් තමයි කන්වර්ට් වෙන්නේ. එහෙම නැතුව මේක කපලා බැලුවොත්, if you cut this into half and see, you cannot see that entire thing has turned into copper. But only part of that is turned into copper. Okay? So that is called single displacement. හේතුව මේකේ තිබ්බ එකක් ගැලවිලා ගිහලා අනිත් එකට හයි වෙනවා. Only one element. But there's something called double displacement too. So let's see that reaction. So I'll provide you the slides. Right? I'll send you the slides after the lesson. Otherwise, it will take some time to write down. Right? Okay. So this is another one. Copper sulfate and sodium hydroxide. What is sodium hydroxide? Sodium hydroxide. Yes, sodium hydroxide. මොනවටද අපි පාවිච්චි කරන්නේ sodium hydroxide? We are using that for several tasks. ගොඩාක් දේවල් වලට අපි පාවිච්චි කරනවා sodium hydroxide. It is a base. එක භස්මයක්. It is a base. So we are using mainly for පහුගිය දවස්වල එහෙම ටිකක් කියවුණා sodium hydroxide කියන වැඩිපුර.
Soap?
Yes, making soap. හරි saffronizing paste. saffronීකරණය කියලා reaction එකක් තියෙනවා. oil වලට නැත්නම් coconut oil වලට වගේ දාලා අපිට මේ ඒක saffronීකරණයට ලක් කරලා ඒකෙන් අපිට හදා ගන්න පුළුවන් සබන් soap production. Sodium hydroxide can be used, not just soap. So a lot of like liquid soap and detergent. For those things we can use sodium hydroxide solution. That is a base. And copper sulfate, again that blue color copper sulfate, you can mix similar amount of copper sulfate with sodium hydroxide. Actually you need little more sodium hydroxide because copper sulfate, one copper sulfate compound will react with two sodium hydroxide molecules. So maybe you can take 1 to 2. So if both are in the same same saturation level, then you can just you have to take 2 times of copper sulfate, 2 times of sodium hydroxide with 1 times of copper sulfate. Otherwise, just use a similar amount without thinking much. So what will happen? This is a double displacement reaction. So why double displacement? You can see copper and sulfate is there here. Sodium and hydroxide is there. So that will create sodium sulfate, right? Sodium sulfate as well as copper hydroxide. Copper hydroxide is, it is not a liquid, it is a solid. And you can see copper hydroxide in colorless sodium sulfate is colorless, but copper hydroxide is blue color basically. Sodium hydroxide is colorless, copper sulfate is blue color. When you put it to that, the blue color solid is created inside this sodium sulfate solution. So that is called a double displacement solution, because both here you can see, so it will interchange both. Double displacement. Okay, another one. Zinc and hydrochloric. This is necessary. So normally I said this last week also. Zinc and battery acid. Yes, zinc and battery acid, or zinc and sulfuric acid. Right. So that will react. So what you can create? Zinc sulfuric reaction, or zinc and hydrochloric reaction. Yes, what it will create? Why there is a blue flame in this setup? Why there is a blue flame? What's the reason? Is it oxygen? Zinc is Zn, right? Hydrochloric is HCl. HCl. You have chlorine, hydrogen. In zinc you have zinc only. Zn, zinc. Zinc, hydrogen, chlorine. So what is here then? Hello? Yes. What will be created? So there is a gas creating a blue color flame. How this blue flame comes? It is like you have to fire this, you have to like burn this, then only the blue flame will come. But this gas is burning gas. What is this burning gas?
Hydrogen.
Hydrogen, exactly. So you can see, so this is then some planets. Let me browse. Oh, sorry, I have to type there. Okay. Okay, just browse and just look some videos. Just search and look some videos about the Uranus. Right? Uranus is basically blue color. Just explore that and see, and why this blue color is there. Right? There are burning reactions, and just see about Uranus. And but the thing is like it's not basically, so it's not a okay, so not in this, sorry. Okay, I'll show you that video. Now, cannot exactly remember this. How to browse that. Anyway, please let me I'll send that to the group. You can just watch that video. There's a nice video, but here it's not showing that video. Okay, I'll show that later. Doesn't matter. Okay, anyway, this blue flame is created using hydrogen, because in this reaction the hydrogen gas will be created. You can see when zinc is put into this. So how can we find zinc? Sorry, I got disconnected. Okay, how can we find zinc? Yes, zinc කොහෙද තියෙන්නේ? Zinc කොහොමද හොයාගන්න ලේසි? How to find zinc?
Inside the battery?
Yes, inside the dry cell batteries, right? Inside dry cell batteries, zinc is there. You can just use dry cell, like all dry cell battery, and extract zinc. That zinc you can put into HCl or sulfuric or any acid, so that even citric acid, it will react and it will emit hydrogen. You can see these bubbles are hydrogen bubbles. Actually, if you put, so be careful when you are doing this practical. So don't put large volume, large amount of zinc and citric, or large amount of zinc and HCl. Just use very small amount, otherwise this will blast, right? So, you know, have you heard about hydrogen bombs? Right, there are bombs using hydrogen because it is blasting reaction. When the volume is so high, it will blast with the pop sound. But volume is little high, so when volume is little high, it will blast with the, not blast, actually you can hear a pop sound and the fire. But the thing is, when this is like too much hydrogen, it will definitely blast. So don't, so this is when you are doing this practical, use very small amount of zinc and very small amount of, actually zinc will dissolve in this, creating zinc chloride. After some time, you will not be able to see zinc. Instead of that, you will see it is dissolved in the solution, creating zinc chloride. Okay, the magnesium one, I think we have discussed that last day, right? Magnesium is creating a bright flame when burning, because it will create magnesium oxide, and so it will basically react with the oxygen in the environment. Now new element is added. This is called, here also you cannot see new element, but here you can see in the environment, oxygen is reacted with magnesium when it is burned, and it is creating magnesium oxide. It's a white color dust. Acid-base reactions, again, so this is HCl, sodium hydroxide, will create H2O and salt. Actually, it will create salt water. When you put HCl, hydrochloric acid, and sodium hydroxide, so it will create H2O, means water and salt. HCl, some amount of HCl is inside our stomach also. Why is HCl is there inside our stomach? For what reason? HCl තියෙන අපේ බඩ ඇතුලේ. සමහරවිට කෑවේ නැති වුණාම එන ඇඹුල් රහ. උගුරට එනවා. Why there is little amount of HCl inside our body?
To digest food.
Yes, for the digestion purpose. Like when we take food, it will digest by reacting with this hydrochloric acid. So basically what we do when like you will get gastritis, we will take some pills, omeprazole, or sometimes like Diagene. Right? It will react with extra HCl and emit some gas. That is the reason, and it will anyway mediate. It will reduce the gas like the acid level in our stomach. That is why we are taking such pills. Okay. Anyway, acid-base reaction will create H2O and sodium chloride. That is salt. Okay. In this lesson, we have done about these type of reactions. So synthesis is just mixing two and creating one element, or mixing few and creating the one element or single compound. Decomposition is breaking that into the basic elements that is created, and single displacement is basically displacing one element. Double displacement is happening mutually, displacing both elements, and these are some examples for that. Synthesis: nitrogen and hydrogen create this NH3. This is methane. Nitrogen, hydrogen together create, this is synthesis. Decomposition: NH3, ammonium ammonia is decomposed back to the nitrogen and hydrogen. Single replacement, HCl and magnesium has created magnesium chloride and H2 hydrogen. HCl and the metals and basically metals and acids will react and emit hydrogen. That is basically happening. Even magnesium, HCl will react and magnesium chloride and hydrogen will be emitted. Double replacement. So you can see sodium sulfide and calcium chloride has created CaSN and NaCl. That is double replacement. And there's something called combustion. So I couldn't explain that. Combustion is basically, so you can see this, this is CH is reacted with oxygen, has created carbon dioxide and H2O. This is actually totally new compounds. Nothing, it's totally new compounds created. So both are sharing this oxygen. So H2O, H is taking this and oxygen, created H2O. Carbon is also taking oxygen, created carbon dioxide. Both are sharing that oxygen. Okay, that's it. I don't think I am too fast, but I have done the lesson related to chemical reactions. You have to fill this table as a homework 8.2. And so these are the things that we can see when there is a chemical reaction. It can be emission of gas, change in color, change in temperature, right? It can be cool or hot, right? Based on the reaction. Some, like when some reactions are happening, the test tube or this will become, the setup will become hot. Some will, when some reactions are happening, it will become cool. And formation of precipitates. Precipitates කියලා කියන්නේ අවක්ෂේප කියන solids. අර solid එකක් හැදුනේ අපි ඔයාලට මතකද that has happened in that so copper sulfate and sodium hydroxide reaction. So that there was a precipitate. Actually, it was not mentioned as precipitate there, but this is what is created. This one is called a precipitate. So copper sulfate, sodium hydroxide, the solid that is created is called precipitate. Because both are here, you can see both are the solutions, no, both are liquid. These liquids form solid. So basically that is that kind of reaction. So what the solid that is formed is called precipitate. අවක්ෂේපයක් කියලා කියනවා. Formation of precipitates. Some are like hydrogen when burning, like it will create pop sound. So production of sound or light even can be light. Production of an odor. What is an odor? Odor. Yes. Production of an odor. In which reaction this odor is formed? Yes. Production of an odor. In which reactions? Yes. A fragrance or some kind of smell, right? Fragrance or smell. සුවඳක් හෝ ගන්ධයක් අපිට කියන්න පුළුවන් odor. So that can also be. So basically, if a reaction form ammonia, right, we can feel that smell. Ammonia, then ගොඩක් වෙලාවට ඔය මේ methane වගේ මේ මොනවාද biogas හදද්දි. In the biogas reaction, it emits methane. That smelly, right? That is also odor. Okay, these things now we have learned. Magnesium oxide one. Now we need to learn the law of conversion of mass. So that we need to discuss. And what else? Yes. Combustion here. Combustion is also there. Fire triangle. Yes, there are things to discuss. I think we can do that next day, right? Yes, let's discuss that part next day. This is long lesson. Okay then, good night.
Good night, sir. Thank you, sir.